And now we have here another invited lecturer from the Faculty of Science here in Zagreb.
Okay, thank you very much. So my name is Tomislav Ivankovic. I work at the Faculty of Science, University of Zagreb, and my main area or field of research is microbiology. So I'll talk to you a little bit about bacteria in the water, the bacteria we drink and swim in. So the regulations are actually very important in this field about water quality. So all the laws, regulations, and administrative decisions in Croatia are published in the so-called official gazette. It's called Narodne novine in Croatia. So this is an official paper of the government where all the laws, regulations, and everything is published, and it's freely accessible to everybody. So you just type in what you're interested in the Google, and then you can see all the laws. It's freely open for everybody. Now, I will talk about Croatian regulations, but I'm quite positive that in the European Union, it's practically the same because we needed to, let's say, justify our regulations to be in line with the European Union. I cannot talk about the rest of the world, but I can say that mostly everything that I will talk about Croatia is also applied to the European Union countries. Okay, so I suppose in all the countries there is some kind of official gazette as there is in Croatia. So these are the current regulations. First is the regulation of the water quality standard from 2019. Then there are rules for water for human consumption. I will not read everything because it's too long. So this regulation is about the water we drink and use in human consumption from 2017. Then the regulation for the swimming waters from 2014 and rules for the swimming pools and pool waters from 2020. Okay, so let's start with the first one, the regulation of the water quality standard. So this regulation applies to surface waters, lakes, rivers, and other water bodies. And in this regulation, for example, you will go to Plitvice, okay, you will see Plitvice and maybe some other rivers, lakes, or whatever. So all the water bodies in Croatia are standardized in these categories, so by their ecological status. So either they are very good, colored with blue, good, moderate, bad, or very bad. And this is, let's say, a guide how to classify the water. But basically, you have a lot of parameters, and usually the worst parameter is the one that determines the water quality. So if you have, I don't know, mostly, let's say, green color, but you have the red color of one or two parameters, then the water is classified as red or very bad. Okay. So let's get a little bit more inside the water quality standard. So these are the indicators. So you have the biological elements, hydrological regime, basic physical chemical, and specific pollutants. Okay, biological elements. So these are the composition and abundance of aquatic flora. So you determine the phytoplankton, phytobenthos, and microphytes. Do you know what these terms are? Mostly, yeah. Okay, so let's go on. Then you have the composition and abundance of macrozoobenthos. You have the composition, abundance, and age structure of fish, and also hydromorphological elements accompanying biological elements. So all this is determined. For example, in our faculty, we have a group that is working with the vertebrati and also vertebrata, the spine and no spine animals. And they are, for example, determining many of these parameters for our regulation bodies. So these are the biological elements. Then the hydrological regime, it's, as it says here, quantity of water flow, connection with underground water, continuity of the river, etc. So these parameters are all important for certain parts of the country, okay? So you'll go to Plitvice, and Plitvice is in the, let's say, mountain part of Croatia, and I don't know how much you know, but the whole land is made of limestone, so calcium carbonate, which water dissolves, and so you get holes in the ground, like caves and everything. So, for example, for all the rivers in this area, it's very important, this connection with underground water. So you have a, well, I don't know how they say it in English, but you have the river that flows, then it goes underground, and then even a few hundred kilometers further, it goes up and then starts to flow again, okay? So, for example, this is very important for this area, you know. In other parts, it's important, the connection with the sea, and also irrigation in the part of eastern part of Croatia, the Slavonia, where there is a lot of crops and land for growing crops and things like this. So then you have the basic physical chemical elements, which are temperature, oxygen regime, ion content, pH, and nutrients. Also specific pollutants. I will not read everything, but so you know, there's also some kind of specific pollutants that are very important for the ecological status that are also being determined. And then when all of this is determined by scientists or people who do it, for each year, the main government institution, which is called Croatian Waters, publishes a report on quality of surface water bodies. So, for example, this is for 2020. It takes them like a year or two, you know, to accomplish. So let's say this is the latest one, and this is how it looks. So you saw the colors before, and then you have, for example, here it says Republic of Croatia, Adriatic water territory, the territory of the river Sava, and territory of the river Drava and Dunav. So then you have the how many stations are, which is the quality of the water. Why these three areas? So the Adriatic Sea, it's important because all the rivers are inside that go to Adriatic, okay? So they discharge in the Adriatic. And the rivers of Sava and Drava and Dunav are very important because they all end up eventually in the Black Sea. And the Black Sea, well, maybe even 15, 20 years before, it was recognized that the Black Sea is getting really polluted by all the rivers that go discharge into the sea. And so we are also part of this Black Sea discharge. And we are obliged, as a country that is in this Black Sea discharge, obliged to follow regulations not to put too many nutrients, which all end up in the Black Sea, and they not destroy, but lower the quality of the sea. Okay, so this is the areas that are very important, but I'm showing you this just so you get a picture how it's done. This is another one, for example, this is for the biological elements. Okay, so you have the phytobenthos and everything. And then also with the colors, it is graded. How is the ecological quality of the waters? Okay, but what about bacteria? I showed you many parameters, okay, but none of the bacteria. So how come this is the question? Well, to get to the bacteria, we need to look at the old regulation on water classification for the surface waters from 1998. And there, this is the table. It's also a nice one. This one was in the law. So in 1998, I suppose many of you were not born at that time. You would get a scanned copy of something in the law. Today, it's like modern, but at that time, it was like this. And here you can see the microbiological parameters, which is, it's in Croatian, but I will translate, the coliform bacteria, fecal coliform bacteria, and aerobic bacteria. Okay, so in the 98, there were bacteria in the regulation, but now there is no bacteria in the regulation for the surface water bodies. I cannot say exactly why is this the case, but I suppose it was recognized that for the ecological status, the bacteria were not that important, okay? But remember, the coliform bacteria and fecal coliform bacteria, we'll get back to this later. Okay, but where do we have bacteria? And where do we search for bacteria? It's the rules for water intended for human consumption. Why is this picture? So I don't know, you were in the city, have you seen these kind of pumps? Yeah? Have you drink from it? No? Why not? So you think it's good or not to drink from these water pumps? Give me your honest answer. Huh? Not good. Why do you think it's not good? Come on, speak freely. You don't like the idea of drinking from the water pump, or you think the water is not clean enough? Okay. Okay.
So if it comes from some sewage, I would not like it.
Okay. Thank you for your answer and for the cooperation. So this is the regulation for the European Water Directive. And I think I can positively say that in the European Union, if the water is coming from the tap, it's drinkable, okay? In Croatia as well. So everything in Croatia, wherever you go, in the toilet, in your apartments, hostel, whatever, if you open the tap, it's drinkable. Why it's drinkable? Because there are regulations that say it is okay to drink it. You know, if it wasn't drinkable, it wouldn't be coming from the tap. And as I say, for Croatia, this is 100% like this. And for the rest of the European countries, I'm like 99% sure. Okay. For the rest of the world, I cannot say, but for the European countries, yes. So yes, you can drink from this pump and also from all the pumps in Zagreb. Obviously, we will not drink from the fountains, but in my faculty, we do exercises with the students, and the quality of the waters from the fountain is also drinkable. But okay, I wouldn't recommend because the pigeons are swimming inside and everything, but the quality is good. But from the tap, it's okay. And also, I'm glad you told me you have, let's say, reservations for this, because I'm constantly fighting with people around me and trying to show them, even to my own family, that the water from the tap is drinkable, okay? And I will show you now this little movie. It's official movie from the pages of the European Commission, okay? Let's just start it. Okay, it's a little bit delayed because I was using the screen video recorder, so it took me a little bit.
Drinking water. And so the European Union is updating its legislation to make tap water even safer. Quality standards will be revised by tightening limits of contaminants and taking into account pollutants like microplastics. The new rules also call on member states to further improve access to drinking water by installing water fountains in public places.
On voulait, en tant que Parlement européen, encore aller plus loin, que l'eau devrait être effectivement aussi dans les restaurants, être gratuit ou à un prix modéré, parce que justement le côté environnemental est très important, parce qu'on sait que juste pour le transport de l'eau d'une bouteille, ça coûte beaucoup plus d'énergie, donc c'est aussi plus nocif pour le climat.
The revised Drinking Water Directive is also a chance for the EU to make progress towards its climate goals. Drinking tap water is good for the environment and good for your wallet.
Pour votre portefeuille, c'est très important, une grande différence. Pour le prix d'une bouteille d'eau minérale, vous seriez livré peut-être 700 litres d'eau du robinet.
The new rules aim to reduce consumption of bottled water, which will help to cut back on plastic waste and save EU households more than €600 million a year. Europeans should trust that their water is safe to drink. Consumers will be able to get up-to-date information about the quality of their drinking water on their invoice or smartphone app.
Okay, thank you for your patience. So let's move on to see what is the regulation about this. So I'm saying this is Croatian regulation, but for the European Union, it's practically the same. So these are indicators that show us whether water from the tap is good or not. So these are microbiological, chemical, specific pollutants, and radioactivity. I will concentrate on the microbiological indicators, which are the following. So in the tap water, the microbiological parameters are bacteria Escherichia coli and the Enterococcus, and also Clostridium perfringens and enteroviruses. Do you know about these bacteria? Anything? Yeah, just basic stuff. Basic stuff is enough. Okay, good. And you have here note 1 and note 2. So note 1 for the Clostridium, it is needed to be determined only if the water is surface water of spring. So surface water or the spring water. And what do you think, for example, in Zagreb, the water you drink, where it comes from? Do you have any idea? So it's from the underground. So you have the surface water that you can drink, you have the spring that you can drink, but also many of the water in Croatia comes from the underground. For example, Zagreb, lies on the big basin of underground water, which is of high quality, and it's coming to the tap. Also coming to the bottles of Yana. I see some of you are drinking. This is from the same basin. Okay, so the water in Yana bottle is the same water that is coming from the tap, only it's a lot more expensive. As I said in the movie, for 1 liter of bottled water, you can have 700 liters of water from the tap. And now with the prices going high, I think the ratio is even bigger. Okay, and the viruses, note 2, store your determinant once a year during the monitoring, and if you need often, then you do it often if it's you see that something is wrong. So basically, you determine the bacteria Escherichia coli and Enterococcus. So let's remember these 2 indicators, okay? This is from the This is for the bottled water. So again, you have Escherichia coli. So before the table was for the tap water, this is from the bottled water. So you have the Escherichia coli, Enterococcus. The colony is growing on 22 and 36 degrees. These are the, let's say, normal saprophytic heterotrophic bacteria, and also the new one, Bacteria Pseudomonas aeruginosa. And as you can see, for the water to be drinkable, you are allowed to have none in 250 milliliters or none in 100 milliliters of tap other bottled water. But you're allowed to have saprophytic bacteria in a certain small amount. Why do you think that is the case? You have any idea? Well, obviously, if you are allowed to have them in the regulation, they're not dangerous to your health. So some certain small amount of the bacteria, the saprophytic bacteria are the ones that are, let's say, everywhere around, normal bacteria found in nature. So if you have a certain small amount in the water, it's okay to drink it because it's completely safe. When I say completely safe, then it's 100% safe, okay? So from these bacteria, you cannot get sick in any way. Okay, so let's move on. Regulation of the quality of swimming water. So these are the indicators. Swimming water is the one, for example, if you have a lake you want to swim in, or you have a river, or you have a sea. So if the government says it's good to swim, then it means they did checking from these regulations. And also you can see here the Enterococcus and Escherichia coli. But now this is not 0, but it is allowed to have a certain amount of this bacteria in the water. So either it's less than 200 or 500, but it's allowed to have them. Why is this? Because in the swimming water, these bacteria, we'll talk about them a little bit later, but now, not to confuse you, the Escherichia coli and the Enterococcus are normally found in gut, okay? In gut of humans, but in gut of every other animals with the vertebra or the spine. So if you have a lake and you have fish inside, you will have some of these bacteria. If you have a lake and you have let's say, pigeons coming inside or the swans or whatever, you will have some of these bacteria, but not too much. And the regulation says if you have it less than this, then the water is good to swim. In Croatia, everywhere the water is great. So this means great and good. So the water is great to swim. If you have time, you can go to the Lake Jarun. It is, well, close here, and you can have a swim. It's completely safe. It's a nice lake where you can swim in and check it out. Also, when you go to the sea, yes, you can swim everywhere if you will go. In the Plitvice National Park, you could swim, but it's forbidden, unfortunately. But the water would be good for swimming inside. Okay, and this is the last one, the rules for pool waters. And these are microbiological indicators. And again, you can see Escherichia coli, the bacteria Pseudomonas aeruginosa, but we have some new ones, which is Legionella, Staphylococcus, and also you have the saprophytic bacteria. Okay, so let's move on. These are, let's say, combined microbiological indicators for all the waters, whether you drink it, yeah. Yes. Right. For the pools, you can't. So you're wondering why is this? Right? So you're wondering why is this? Because swimming water means water, the surface water, natural water body. So basically, it's impossible to have a natural water body without the Escherichia coli inside. And for the pool waters, they are mostly filled from underground sources, for example, in Croatia, or they are filled with tap water, and they are even chlorinated, to destroy whatever left inside. So in this case, the Escherichia coli should be 0 along with all these other bacteria, because obviously you cannot drink it because it's very heavily chlorinated, but you cannot have it inside, and it also shows the effectiveness of chlorination. So if they have the bacteria inside, then it means the chlorination or the other, it's chlorination almost in every pool, is not working. And also this Staphylococcus aureus bacteria, it's a new one. It's also an indicator of how good the chlorination of the pools are. Okay. So the combined microbiological indicators for the tap water, for the pool water, and the swimming, and this is the Lake Yarun I was telling you about. Okay. So these are the combined microbiological indicators. So in all the regulations, you have the coliforms, Escherichia coli, and Enterococcus. So these are the same indicators for all the water. So the Monas aeruginosa, you have it for drinking water coming from the bottle and also for the pool water. And these bacteria are, let's say, specific indicators showing for the certain type of water. But in any case, in the water, you must not have, or you can have in very small amounts, the Escherichia coli and Enterococcus. And now let's see why is this. Okay, let's move on. So how many of you have heard about Jon Snow? Can you raise your heads if you heard about Jon Snow? Okay, it's a famous character from the TV show Game of Thrones. If you didn't know, these walls are in Croatia, in Dubrovnik, where the show, part of the show, I think it's called King's Landing, right, is being filmed. Okay. Why am I saying this? Because obviously to show Dubrovnik and beauties of our country, but also to ask you, have you heard about Jon Snow? Have you ever heard about Jon Snow? Really? That's very nice. Okay, great. Even the Google doesn't know, because when I type in Jon Snow, it asks me, did you think Jon Snow? Okay, but here he is. So this is Jon Snow. You can find him after if you know what you're looking for. Okay, so who was Jon Snow? In my opinion, one of the greatest microbiologists ever. Okay, why? Because he's considered to be the father of epidemiology. And why? Because in 1854, he managed to prove that cholera epidemic in London was caused by a specific water pump and not by miasma, as it was common understanding at that time. So he suggested the term waterborne diseases. This is how he, let's say, managed. But why he is considered to be the father of epidemiology? Because he managed to stop people drinking from this pump, which is still there in London, and that's how he prevented further epidemic of the cholera and saved, let's say, thousands of lives. And why the father? Because even now we are saving millions of lives every day and every second on the basics that he made. And now I will take a little break from speaking, and I want to show you a great little movie. It's around 8 minutes that will talk about Jon Snow, so it helps me not to talk and save my breath a little bit, okay? So just an introduction, this is a great documentary about the sewage system being built in London, and it says about this great cholera epidemic, which was at that time in London. Then I stop. Okay, so the documentary continues on how they built the first sewage. So if you haven't known, London had the first modern sewage in the world. So, pioneers, let's say, all the sewage that we have now. Okay, so let me ask you one thing. Apart from the point that you should drink beer, not water, because it's good for your health, what else can you take from this story about Jon Snow or the movie? Something maybe a little bit broader or personal. You have any comments, maybe? So it was 150 years ago, okay? it was a common knowledge or common understanding that all the diseases are caused by miasma. Have you heard about this word, the miasma? It's the foul air that makes you contagious. Now we know this isn't the case, okay? Jon Snow also knew it, but when he showed it, he was considered to be, I wouldn't say stupid, but let's say very wrong, okay? So what I get from this, not the story, but the history that is showing is, if you have some kind of new revelation, which is really revolutionary, you will for surely be opposed, okay? So maybe that's something you can take in the future in your life. But also, even more important, if somebody in your community has a new view or new idea about something, do not consider it immediately to be wrong, okay? Because it can be that everybody else is wrong and one person is correct, as it was shown in this case, okay? So if we all in this room have one opinion and somebody has a different one, it doesn't mean that he is wrong. So I think everybody should have open mind for everything. Okay, so that's why I think Jon Snow is one of the greatest microbiologists, but also persons in history. And also the character Jon Snow, although I didn't, sorry for the spoiler, I didn't like he killed his own wife in the end, but okay, let's move on. Okay, so let's get back to the bacteria I told you, the Escherichia coli and the Enterococcuses. So the only way to prevent diseases such as cholera or typhoid fever or dysentery or any other diarrheas is to have one system taking the sewage out and another bringing fresh water in. And they must be completely separate. So if mixed, all of the named diseases quickly spread to population and cause epidemics. So this is how it's transmitted: oral, fecal, and fecal, oral. Okay, so let's remember this. Also, this is another movie about the cholera epidemic outbreak in Yemen. It's maybe 2 minutes to show what happens when you don't have these kind of two systems, okay? Because, well, I don't know from what part of the world you're coming from. I suppose mostly from the European Union, as me from Croatia. So it is common for us, okay, to have a sewage. You go to the toilet, you do your thing, and then you come back. And you also have the tap where you drink the water, which in many parts of the world is not so. So this is just a little small, let's say, scene of what happens when you don't have the separate systems for the sewage and for the water coming in. This is a recent one, so that's why I'm showing it.
Diseases spread mainly through contaminated water. Hospitals and most large cities, including this one, lies are crammed with patients. Severe adult children are among them.
I have 3 daughters and 1 son. They've all been vomiting and have diarrhea for 2 days. Now they're in hospital.
Cholera is also spread by eating contaminated food. Rations to eat are hard to find. Victims have been on strike for several months and receivers were paid. Market and electric power supply. Rain season is getting closer. Downpours are increasing and wash away uncollected rubbish, carrying disease through the streets.
I recall the disease is caused by and food that is contaminated because of flies and dirty water. Everyone has to clean up the garbage and keep themselves clean too.
The translation is automatic, so.
The infection is easily treatable. Agencies have been supplied with medical kits, but the number of patients now far outweighs the amount of medicine available. More than $1 billion in international capacity and profits will explode in Europe. Much of the infrastructure has been destroyed by 2 years of war between the Houthi rebels and the international government of President Abdel backed by a Saudi coalition. This is overload of the land health system is a few years of life. So I call all the international and we also report to this statistics in this different way. Again, we wait for more help from the government. And on the call of this thing, please be honest. Not my picture. All we do.
Okay, so it's happening all over the world, even as we speak. So if we do have things like this, it's not like this everywhere in the world. Okay, now let's get back to the indicators, which I show you to remember. So the indicators in all the regulation are the following: coliforms, Escherichia coli, and Enterococcus, Pseudomonas aeruginosa, heterotrophic bacteria, and these special ones. And what about the diseases? So diseases caused by water or the waterborne diseases are the following. Cholera is the most dangerous one and the, let's say, most famous one. It's caused by the bacteria Vibrio cholerae. Typhoid fever is caused by the bacteria Salmonella typhi. Dysentery by the Shigellas. Also, you have the bacteria Clostridium difficile, which causes the so-called diarrhea and colitis. And also you have organisms like these ones. So enterotoxigenic Escherichia coli, Campylobacter, Cryptosporidium. This is a parasite, Cryptosporidium giardia. And also you have the viruses such as rotavirus or enteroviruses, which all cause, together with this, the so-called traveler's diarrhea. Have you heard about the term traveler's diarrhea? Yeah, have you ever had one? I mean, if you travel to countries that are, let's say, outside of Europe, it's common to have the diarrhea because your gut is accustomed to one type of bacteria, and then you get exposed to another organisms, which include this, also from the water, and then you get the so-called traveler's diarrhea. Fortunately, it goes away in 2 or 3 days. Unfortunately, if you are on a vacation for 7 days, you spend 3 days on the toilet. So, but what can you do? Also, good one, after the diarrhea, you're much thinner, so you can go to the beach, okay? You lose a little bit of intracellular water. So let's say before the beach, it would be okay to have it. So why am I showing this? So you see these bacteria, but these are not the indicators, okay? Why is this the case? So indicators are, well, what the name says, they are indicating on the disease. So if we get some water, we don't have to show that inside the water there is Vibrio cholera or Salmonella or Shigella, because maybe there is not. And if there is, it is quite difficult to find it, okay? But if you find in the water the Escherichia coli or the Enterococcus, this means that the water has been contaminated with the sewage, okay? So these bacteria indicate that the water drinking or swimming or whatever is somewhere connected with the sewage. So it shows that there is a possibility of having these bacteria, and that's why we don't use such water, okay? So this is, let's say, very important to remember that we have indicators that are not causing sickness by itself. So Escherichia coli is not pathogenic, also Enterococcus, but it indicates on the possibility that the sewage is entering somewhere the drinking water. Escherichia coli, you probably know a lot about it, but I will just say it anyway. So it's a common bacteria that is found in the gut, where it creates a normal microflora of the gut, and also for the Enterococcus. These other bacteria are also indicating something. So the Pseudomonas aeruginosa and heterotrophic bacteria are indicating that the water is, I think the stale is the right word. So for example, if you have a well, or you have a tank of water, if the water stays inside too long, then you will find Pseudomonas aeruginosa. If the water stays inside too long, then it's possible to have the parasites, which is also not good. You don't want this, so it indicates this. Okay, so how do we search for these bacteria? I will go shortly through this, but I think it's important to know. So if you want to see if the water is good or not, you take the sample. For example, I don't know, have you done something like this before? Has anybody here had a microbiology course in the university? Have you done the water analysis? Yeah? Okay, so how did you do food analysis?
Analyze if it's number of bacteria or Salmonella or Clostridium, and that, for example, yeah, that's like primary isolation depends on what you want to accomplish. And there was also a protocol for like meat, what you have to do, or for milk and eggs, or for I don't know, spices and stuff. So we basically followed what's proposition of European Union for which analysis should be done.
Okay, great. And do you remember how did you search for salmonella in the food?
To analyze salmonella. On first day, we would just leave it in that on a 41 or something. And then tomorrow we would transfer it in Miller Kaufman, I guess.
Okay.
And then on the third day, we would take the sample and put it on the pantry plate, so we could count if there are bacteria. And yeah.
I have to say you have been paying attention in your classes, which is really nice. Great. Thank you for your input. I saw somebody else was saying they did the water analysis, right? Yeah, somebody here? You raised your head. Okay, can you tell us in short?
Small amount of the water and leave it to incubate for, I don't remember how many days it was. I think at least 48 hours. And then we look if we have any colonies, and then we, with those colonies, we did another plate to have more sample.
Okay, and have you used the so-called selective media? Okay, so as I don't know how your background in microbiology is, I will just say it as I say shortly. So in the water, let's say the tap water, we want to show that there is no Escherichia, there are no Enterococcus, and there is no Pseudomonas if the water is from the bottle. So how do we do it? We take the sample, we concentrate the sample. So you saw it has to be in 100 milliliters. Okay, so we concentrate the sample by taking it through the nitrocellulose filter. We do the vacuum filtration. So all the bacteria in this 100 milliliters remains on the so-called filter. The filters are this. There are small papers of nitrocellulose, which then, when you let the water going through, you put it on the so-called selective media. Why? Because there are a lot of bacteria inside, and we don't want everything to grow. We only want to show if there is Escherichia or Enterococcus or Pseudomonas aeruginosa. And these are the samples. So when you put your paper with the bacteria on the so-called rapid E. coli 2 agar, it's just one of the many that we use, but it's a really nice one. Then you have the colonies of different color, okay? So the blue colonies are the so-called coliform bacteria. So they are all, not all, but majority of the bacteria living in the gut, and Escherichia coli is one of these bacteria. But Escherichia coli grows in the purple color. Why is this? Because in the media, you have some kind of supplement. So the Escherichia coli has the enzyme, which is called beta-glucuronidase, like a beta-glucuronidase, yes. So this enzyme breaks the supplement and the colonies grow in purple. So if you have purple colonies, then the water is not good. For the Enterococcus, we have the so-called Slanec-Bartley agar, which is a selective media. And if the bacteria grow, they grow in this red color, which shows you there is Enterococcus inside the water. For the Pseudomonas aeruginosa, this is my favorite selective agar. Why? Because it glows in the dark. So the Pseudomonas aeruginosa bacteria produces a pigment that is called piocyanin. And this pigment, when you put it under the UV light, it fluoresces. So here you can see there is a lot of bacteria growing, but you can see the Pseudomonas aeruginosa, which is glowing with this pigment, and then you can see if it's Pseudomonas aeruginosa or some other type of Pseudomonas. So this is basically how we do it. We take the water, we put it on the selective media. If it grows, it's not good. If nothing grows, then the water is drinkable. So it's basically pretty simple, and it is done regularly. So you know that the water you swim, for example, or the water you drink is good for your health. But this is only, this can help you, let's say, after. So the thing that prevents the waterborne diseases to spread is, as I said before, to have the separated sewage and the separated system bringing the water in. So take-home message would be this: stop this, the feces and the sewage, getting connected to this, to the drinking water. Okay, before I move to the next part of the lecture, are there any questions or comments or whatever? No? Yes, please.
Have you ever swim in the Yarrow?
I have swim in Yarrow many times because I will tell you now. Okay, I will be freely and open, yes. So people in Zagreb, they are living very close to this beautiful lake called Jarun. It's, let's say, 15 minutes with the tram. I don't know any other major city in Europe, maybe you can help me, which has a beautiful lake almost in the city center where the people can swim in. Is there something like this in the towns that you come from? Maybe yes, okay, but I have never seen it or I don't know about it. But the people from Zagreb are so reluctant that they consider the Jarun to be, I wouldn't say like a septic tank, but let's say something that you wouldn't swim inside even if I don't know what happens, which is completely wrong. So the water in Jarun is a perfectly good water to swim. And in my classes, I do the practical classes. We do the analysis every year just to show the students the selected media and everything. And since I've been working for 15 years now, every time the water from the Lake Jarun was perfect, it means great to swim inside. But still, people are really reluctant. Yes, I have swim myself. I also took my small children. We all swim inside the lake because I believe that my analyses are good. Nothing happened. We were all safe. We didn't even get the traveler's diarrhea, so I can say it's good. And also, I believe that the government, when it does analysis, and it says to me that the water is good, I believe, and because I know they do it correctly, and that's why I can say that yes, the water in Jarun is good, and yes, I have swim. It's really beautiful. So if you have time, you can go check it out and have a nice swim. It's not so far. Okay, so let's move on. So I said it's very important to stop this from going into the water. So this is the sewage. But what about the sewage? How do we treat the sewage? Which will be the next part of my lecture. So why did I put this, the fire and forget tactics? Because my opinion is that most of the people, and not just you here, but also people everywhere, let's say general population, has an opinion or a stand that once you go to the toilet, you take a seat, okay, you relax, you do your thing, whatever it is, whether it's a good one, not a good one, but every day, not every day, but still everybody does it, right? Quite often. And I think that people mostly, when they flush the water, think it's fire and forget. So it's not anymore there. It's not bothering me. The smell sticks a little bit, but still I cannot see it. So everything is good. It's gone. Well, it's not gone. Okay. So we need to treat your feces, whatever you took out of your body, it needs to be treated. Okay. So it's not gone. It didn't magically disappear. Also with the garbage, I also have an opinion, and I think I'm right, that people take a garbage in a small bag, okay, they put it in the bin or they put it outside of their house. In the morning, it's gone. Wow, magically it disappeared. Well, it didn't disappear, it stayed somewhere, okay? So we all have to be responsible for the garbage we are producing every day, whether it's our feces. Now, at this moment, it's a part of us, okay, it's still here. Tomorrow, maybe it will not be, but it didn't disappear. Okay, so how do we treat the sewage? What do we do with our feces? I don't know if you have any background about this. Yeah, no? Okay, it's nice if you don't have, so it makes it a little bit more interesting, but if you have, please stop me and say your opinion. So it's not a fire and forget tactic because we need to take care of it. So these are the main tactics, how to treat our feces and the sewage. So the septic tank discharge into the sea or river or the wastewater treatment plants. Do you know what a cesspit is? I think I'm pronouncing it right. I don't know. Cesspit, yeah? Do you know what it is? Who knows? Please tell us. Simple.
Mostly on our countryside and some, it's not in the cities, but it's like not connected to some system of a switch.
Okay.
It needs to be emptied every, I don't know. But it needs to be emptied so it can store our pieces and everything for some time. But then after that, it needs to be emptied and taken somewhere else.
Very nice. Okay, I have the pictures here. So the cesspit is what? It's a tank that collects our feces. Okay, so we don't want to have it in our houses. Do you know what they did, let's say 150 years ago with the feces from the house? The forest. But if you're in the city, you took it in a bucket and then you throw it out of the window. Or if you're not in high place, you throw it out of your door. So that's how they did it. But then they made a cesspit, so it's a tank, okay? It collects feces, and when it's filled to the top, you can empty it, and then you have another tank, okay? So it's a method to stop preventing sewage to going into, let's say, well, which is also close to your home. I have to say, in Croatia, many cesspits are, let's say, ingeniously upgraded in the term that they threw a hole in here. So it makes a hole that's going to the ground. So the feces is collected, but slowly it's going to the ground. Of course, this shouldn't be like this, but as I said, it's a ingenuity upgrading. But the real cesspit is just a tank which collects the feces, and then you not flush it out, but you take it out and then fill it again. Similar to cesspit is a septic tank, but it is more advanced. Septic tank, have you heard about this one? Yes? Who does? Who did? Can you tell me a little bit about septic tank? Why are you not using septic tank? I mean, you have a sewage. If you don't use septic tank, then you have a sewage, okay? Does anybody use septic tank in their house? Okay, not in the house. But if you live, for example, in the country, okay, where somewhere outside the major, not a city, but major place, the septic tank is actually a great way to do the wastewater purification because it's a small wastewater purification plant. So what is it? You have it's mostly made of concrete, so you have a concrete tank where the feces and the sewage from your house goes inside. So what happens when it goes inside? It creates sludge, okay? So the heavier stuff goes to the ground, and here you have the water, and on the top you have it's called scum, okay? So it's a foam, or let's say detergents, whatever goes and floats on the water. So what happens here? Inside, with your feces, there are a lot of bacteria, okay? So what happens to bacteria when they go into the septic tank? What do you think? Give me your best opinion. What happens? They what? Exactly, yes. So they live and continue to replicate. To replicate, they need to use organic matter, so they use it, okay? So in the replication, they basically clean the water by eating everything inside the whole organic matter. The biomass that is created eventually doesn't have any more food, the bacteria die, and they sink to the ground, which is this sludge. But the water that is here, I wouldn't say it's completely pure, but it's pure enough that it can go through the outlet outside, for example, in the field or a forest or wherever else. So actually, a septic tank is a great wastewater purification plant. What with the sludge? What do you think happens with the sludge? Okay, we will get back to this later. Okay, but if you have a septic tank, what do you do with the sludge? It's flushed, or from time to time you need to get it out. So you invite a great tank, okay, and the people that are doing it, so they're pumping it out, okay, and that's how the septic tank is working. What is with the discharge into the sea or river? So in the river, obviously now all the major cities, or let's say a larger settlements, have a wastewater treatment plant before the sewage goes into the river. But before, it was considered to be a good way to get rid of sewage. Also discharge into the sea. What do you think? Is it good? Of course, if you have a wastewater treatment plant, it's good. But if you don't have, is it good to discharge sewage into the river? No? Okay. But what would you do with it? If you have a large city, okay, you have thousands of people going to the toilet every morning, what do you do with the sewage? You couldn't have a great septic tank. I mean, it would be too large. So why did the people do it before? The wastewater treatment plants. Any ideas? What did you do? So what was the take-home message? What's the most important thing to do? Separate it, of course. So if you have a big city and you have the sewage coming to the river, which flows somewhere, then you have the sewage separated from the water coming in. So it's not the ideal solution, but it's good enough. Still, you are separating it and you have the water coming in, which is good because you have break the oral fecal circle. What happens with the bacteria? What do you think? Exactly. So that's what happens to the bacteria. So if you put them in a river, bacteria from our gut are not accustomed to live in, let's say, fresh water, which is cold. It's not 37 degrees. It has a very small amount of nutrients. So eventually is few days, they will die. They will eat what they can for a few days, and then they will die. So it's not a perfect way to do it, but it's good enough. And what about the discharge into the sea? What do you think about this? So I will just tell you that most of the coastal cities still use this, okay? Bigger ones are obliged to have a wastewater treatment plant, but let's say 20 years ago, the sewage was being discharged into the sea without any problems. How is this possible? And is it good?
They will either die or be consumed by something else.
Exactly. So if you discharge sewage into the sea, all the bacteria that can cause any disease, such as cholera, typhoid fever, or whatever, will die in, I think, 5 to 7 days is maximum. So what is important and what is being done and has been done is that the discharge is not close to the coast. Because if it's close to the coast, then if you discharge it, in 3 or 5 days, somebody could get sick. So what the people did, they calculated how much from the coast you need to get the pipe, so the water, even in theory, cannot come back in 5 to 7 days. So they calculated the distance and also taking in account the currents, okay? So if you have a current that is taking the water straight to the coast, you will not do the discharge there. If you have a current that will take the sewage into the open seas, you will do the discharge there. So you discharge, the bacteria go in the open sea, and eventually they die off. So it's not an ideal way, but it's good enough. Okay, and now.
But if you drop it in the river or in sea, I can imagine that like you have toilet paper, you have feces. So, yeah, does it have an impact on the whole ecosystem that was naturally there before this start our city?
Yeah, of course it does. That's the part, it's not ideal, but it's good enough. So let's say we have a hierarchy, okay? So the most important thing is not to have people dying of cholera, okay? So that's why you do it. Of course, you will have an impact of the ecosystem, but actually it's not that big. The toilet paper, yes, it could be a problem, but it's also made of cellulose that dissolves very quickly. So basically, we'll have an organic compound. It's like throwing the leaves in the water. It will dissolve. The bacteria stay there a little bit. They are eaten by, I don't know, some kind of plankton, or most of them are diet of bacteriophages that are there. So let's say the impact is not so great. And the pollutants, for example, detergents, is also not the biggest problem as you would think, because most of the detergents, I would say 90%, are really readily biodegradable. So there are some that are not. And if you put toxic chemicals to the sewage, of course, it's not good. But most of everything you discharge will be biodegraded. So the impact on the environment there is, but it's not as big as you would imagine. So because it's sewage, it's a, let's say, household common sewage. Of course, for the specific wastewaters, it's not like this, or the industry wastewaters, but then you have regulations that are stopping this from happening. Okay, ideal is the wastewater treatment plant. So let's talk a little bit about this. I'm sorry for your lunch, but I will take, let's say, 20 more minutes, okay? So what about the wastewater treatment plant? As I heard, you're going to visit this. It's the central wastewater treatment plant of the city of Zagreb, yes? Do they know they're going to visit it? Okay. Personally, I think this is a beautiful complex. I have been there many times, and every time I come there, I am really quite amazed about what people can do. Okay. I will take this opportunity and talk to you about wastewater treatment plant in theory. So then when you go there, you will know, let's say, exactly what's happening, and then you will upgrade your knowledge. So the Zagreb wastewater treatment plant is actually a typical wastewater treatment plant. So in every major city in Europe, I would say even in the world, you have a wastewater treatment plant that basically operates the same way. Has anybody been to any of the wastewater treatment plant? I don't know, in your place, or yeah, you have been? What do you think about it? The size of the wastewater treatment plant is calculated on the sewage it is receiving. Okay, so if you have, let's say, Zagreb has around 1 million people. The wastewater treatment plant is projected not for 1 million, but 1.5 million. Okay, why is this? Because it's calculated that every person on average on day makes, I don't know, let's say 10 liters of sewage. But if you have some kind of factories, then you would exert more organic matter. So that's why it is mostly calculated a little bit above the people that are inside. Okay, so how does the wastewater treatment plant works? So Zagreb is here, okay, where I'm showing, and this is on the outskirts of Zagreb. On the right, it's the river Sava. The river Sava is flowing that direction, okay? It's flowing to river Dunav, and then from river Dunav to the Black Sea. So we are obliged not to discharge sewage into the river Sava, but to purify it, because eventually it finishes in the Black Sea. Okay, so the raw sewage is collected from all parts of Zagreb, and it's coming to this central meeting point. So in the morning, if you went to the toilet, I would say by now your shipments are getting here, okay? So it takes a few hours, to get there, and then around 1 o'clock, it's here ready to be purified. Okay, so first you have the so-called pre-treatment, which is the mechanical treatment. So here in these buildings, you have a sieves. The sewage goes through them, and then it separates all the big contaminants. Let's say water, paper, or something else you put inside the toilet. They are mostly mad about the people throwing what in the toilet. What do you think? What you should not throw in the toilet? So you shouldn't throw tampons. What else you shouldn't throw? Wipes, right? Wipes, and what else? When you smoke and you have it's fag, I think, yeah? You shouldn't throw it in the toilet. Why? Because it does not dissolve. The toilet paper dissolves fairly quickly, but this does not, and it ends up in the wastewater treatment plant. So you have the sieves here that are preventing this from going Furthermore, it is collected from the sieves and it goes to the central landfill. Okay. After the pre-treatment, you have the so-called catcher of the oil and grease and sand. Why? Because in Zagreb, but also in many other cities, the sewage is mixed with the how do you say, rainwater. Yes, it's mixed with the rainwater. So when the rain falls, it flushes the streets, and on the streets there are many oil coming from the car traffic and everything else, and also from the sand. So everything this is collected here. Then you have the grease that is also being put aside. It floats on the top of the water, and you have the sand coming down. It is also separated, and then it's also being carried to the landfill. So when you have the pre-treatment, you have the, it's not a clean water, but when you look at it, it looks clean, okay? So it doesn't have big parts floating inside. So it's basically just water with nutrients inside, which have to be removed or purified. So first, it's called the primary treatment. Primary treatment are these big basins. So what happens in the basin? This is basically a septic tank, okay? So in the basin, the bacteria start their job. They eat the organic matter. The organic matter slowly sediments on the ground, and there you get the first batch of sludge, okay? This sludge is being transported through underground, okay, underground tunnels, here in these so-called anaerobic reactors. The water that is now pretty clear, I mean, pretty much more clear than when it entered inside, is being transferred to the so-called aerobic basins. In aerobic basins, the magic happens and the bacteria do it. So have you ever heard about the activated sludge? The term, yeah? Who did? Okay.
They are used in agriculture. They are dependent on the fields. Once at the end of the process, they are used, and they're used in the fields to enhance the culture.
Yeah, but this is not activated sludge. This is the finished sludge. Okay. So yeah, exactly.
Also, at the end of the process, needs to be activated again, so purified from the waste, and then it can be used again and again. So
right,
it's recycled.
So activated sludge is something that was being discovered in the early part of 20th century, when the first wastewater treatment plants are starting to be produced. So the people noticed that if you put oxygen, I mean air, inside a septic tank, then you had a really great purification. And it was considered that somehow the oxygen activated this primary sludge, and it's called activated sludge. Okay, that's why it's called activated. But what happens? So here you put aside most of the sludge, like pieces, big parts, and everything went down. And here you have the, let's say, clean water, which has nutrients inside. So the main job of the wastewater treatment plant is to remove the nutrients, to remove the carbon, nitrogen, and phosphate. Why is that? So the main job is not to remove the bacteria, but to remove nitrogen, phosphate, and carbon. Why is that?
If it's released into the river or somewhere, and that is bad because then it will lead to increased spending of the oxygen, so the larger organisms will not be able to survive in such environment.
Exactly. So the biggest, let's say, contamination of the sewage is that it brings a lot of nutrients in the surface water, which makes the organisms to grow, which are not supposed to grow there. So the wastewater treatment plant needs to remove the nutrients. Here, before you enter the water basins, you have the clean water with a lot of nutrients. So what happens? The pumps pump air here in the basins, and then the activated sludge, which is a consortium of a lot of species of bacteria and also the protozoa, they eat and eat and eat all the nutrients that are inside. They convert the nutrients from the water in their biomass. Why the oxygen? Because it's important, because the bacteria with the oxygen have the fastest metabolism. So it's basically having a septic tank, but on turbo, you know, working really, really fast. Why is it beautiful? You will see when you get there. Make sure to have a big, strong smell here when you see the aerobic basins, okay? Because every good microbiologist can know their environment by smelling it. And also here. So if you smell it really, when I say smell, it's not just like this, okay? But you inhale deeply, okay? You will see it has a very nice earthy smell, which means the bacteria are doing it correctly, okay? So the bacteria are eating all the nutrients and converting it into biomass. The first law of thermodynamics, or the first law of something else, says that everything in the nature cannot disappear. You can only convert it from one thing to another. So the nutrients in the wastewater, you cannot make it disappear, but here you convert it into biomass. And this biomass is being transferred to this final part. It's called the secondary clarification, where the biomass, the bacteria, slowly sediment, and then in the end you have the water that is clear and it goes outside and is being discharged into the river Sava. And that's it. That's the whole story, but not the whole story, because as I said before, you still have your garbage and you still have the sludge which needs to be treated. But for the water, the story is finished. And actually, the Zagreb wastewater treatment plant is so well designed that the water going out is cleaner than the river Sava, which is receiving. So actually, the wastewater treatment plant is purifying the river, which is natural water body. Okay, so what about the sludge? The sludge is what remains. So the sludge from here, primary sludge, and this biomass converted nutrients, it's called the sludge, and it's being also treated. It ends up in these so-called anaerobic reactors. In these anaerobic reactors, the anaerobic digestion is being done. So why do you think they do this anaerobic digestion here in the wastewater treatment plant?
Digestion are usually harmful for the environment, like methane, how you say it?
Hydrogen sulfide, okay.
And they need to be contained, and ammonia also.
Right.
Gases need to be contained, and I know that some wastewater treatment plants have like solvents that collect and contain those gases, so they need to be treated or
right.
Other.
But also, aerobic digestion you already did. So digestion is, let's say, eating. So the bacteria did the aerobic digestion here. So they ate everything you can eat when you have oxygen in your metabolism. But still, there are some nutrients that you can eat if you don't have oxygen, and it's being done by anaerobic bacteria. So this is the final step where these bacteria eat everything what is left, and then in the end, you have the sludge, which is completely, let's say, maximally removed out of nutrients. So you have the final project, which is the waste that cannot be treated anymore. And also about the methane. So methane is actually a natural gas. The methane is being produced, but the methane as a natural gas is a fuel, okay? So this wastewater treatment plant, also the other ones, they have generators here that use methane as a fuel. They create electricity, and actually the whole power plant here, all the mixers, all the pumps, all the everything is being powered by the methane created in the wastewater treatment plant. So the bacteria do it, and they are generating electricity for all of this. Oh yeah, I forget these lines. I was a little bit in advance. Okay. Yes, please.
Even if there's an electricity shortage, it can continue working.
Yes, it can continue working, and basically it's working all the time on this electricity. Even there is sometimes more electricity produced than the wastewater treatment plant needs, so it's being returned to the net. So it's actually making some amount of money. So, as I said before, main goal is to reduce the amount of nutrients. The biological oxygen demand and chemical oxygen demands show you how much carbon there is in the water. The nitrogen and phosphorus are food to the bacteria. And why? Your colleague already answered. Because all of these nutrients cause the so-called eutrophication, which is the, or you may know it as the algae bloom, the sea bloom, where the organisms grow and they destroy the ecological status of the water. So we are now going back to the first regulation, if you remember, the first one. Okay, so if you have many nutrients, then you will not have a good one or the very good one, but you will have an orange or the red, bad or very bad status of your water. So this is the main idea of the wastewater treatment plant, to have the surface water bodies good or excellent. If you don't do it, then you have something like this. I'm showing you recent examples. So this was in Istanbul, Turkey in 2021. In English, it's called sea snot, but you can see here, it's the algae bloom. Okay, so now when we know the theory, what caused this? What do you think? It was very interesting, for example, for me or the people that know what caused it, to read the lines in the newspaper. It was like, foam mystically appeared in coasts of Turkey. What could cause it? How did it happen? What is the problem? But you know what is the problem, so what happened? Right, so they had an excess of either phosphorus or nitrates of carbon. And how can you get the excess of nutrients in the water? Untreated wastewater, okay? So after a few days, the titles of the newspapers changed to untreated raw sewage was being discharged in Istanbul, and that's what caused the algae bloom. And also, one other picture, which is quite interesting, is this one. Why is it interesting? Because this is news from yesterday. I heard it this morning in television, and it says here, the river in Japan's Nara prefecture suddenly turns fluorescent green. And they're also being questioned why, what has happened. Why was it interesting to me? Because this is the picture that I took in Maksimir. Maksimir is a park where is the zoo, and as I understand, it's very close to your hostel. If you haven't been to the zoo, you must go. It's really perfect. I mean, perfect. It's a really nice zoo, and also has a lakes around. So I took this and put it on my official Instagram. So I'm asking you to follow our official Instagram. It's called bacteriology.pmf. PMF is a Croatian abbreviation for the Faculty of Science. So anyway, it's the same picture. What do you think this is? It could be Pseudomonas, but I don't know this large amount. What else? Algae bloom, correctly. So this is for sure algae bloom. And I think this one is also, but today it said in the newspapers that they found some kind of dye upstream of the river that is being discharged, but I'm not quite sure. I cannot say 100%, but I think this is also the algae bloom, the same as this one. And again, it is caused by what? Some kind of nutrients flowing in. I suppose here, maybe it was a hard rain, so it flushed out all the feces from the animals, okay, and flushed it in the lake surrounding it. And here, I don't know what happened, but still, it's quite interesting. Okay. What about the bacteria? So the bacteria in the wastewater treatment plant, even though it is not the main goal, are either removed by disinfection, either discharged in the water, because the pathogenic bacteria die fairly quickly outside the gut. So what about the sludge? I will do this in 5 minutes. So the sludge is, as I said, the final product. So what can we do with it? Okay, so first the sludge is being dehydrated. You see it here. And this is a centrifuge. So like in the washing machine, so the sludge is being turned and the water is going out because it slows down the volume. Not slows, but scales down the volume. Okay. Next, it's being stabilized because stabilization kills all the bacteria that are being inside. First, by biological stabilization or the anaerobic digestion, where the bacteria eat until they basically eat themselves out. So most of the sludge after destabilization, it is on. This is the picture from the wastewater treatment plant of Zagreb. You know, you will see this aluminum pyramids, but inside it is this concrete egg. Inside is the anaerobic sludge. So it eats until almost all the bacteria inside are dead. It lasts around 35 to 40 days on 37 degrees. Then you have the chemical stabilization, where you add inside lime. It makes a disinfection. And also you can do the solar stabilization, which is basically putting the sludge on a huge amount of space and letting the sun go and dehydrate, and that way killing the bacteria. So finally, when you do all this, you can dispose it. That's what the colleague was talking about. So what can you do? You can dispose it on a landfill and it stays there forever. Then you can make a compost out of it. So that's what they can use on the fields. You cannot, you should not use the raw sludge, but if you do the composting, which is done in a proper way, you can have a fairly nutrient-like compost, which you can use on the agriculture. You cannot use it to make crops for people to eat, but for example, you can use it in, I don't know, parks or somewhere like this. So it's not to be eaten, but it's a good fertilization for the plants to grow. And the final way is incineration, where you burn the sludge and you get the ash, which is basically a preferable way because you reduce the amount of sludge in a small ash, and then you can put it on the landfill because you want to get as little as possible. This here, is anyone here from Vienna or Austria? No? So this here is the incineration facility in Vienna. It's almost in the center of the city, and to make it more appealing for the public, they did it in this kind of designer look. It's actually made by a very famous architect, which I cannot remember the name right now, but I'm telling you it's nice and a very famous one.